Hello, Math 2 Extended. This is Unit 3, Lesson 1. We'll be learning to factor expressions today. So you weren't in class, but if you were in class, I had you practice multiplying two binomials together. And you've all multiplied binomials plenty of times, so you know what I'm talking about here. So if we have x plus 2 and we multiply by x plus 5, we have to remember to distribute everything. So we distribute our x, we multiply it by the 5, and we get x squared plus 5x, and we distribute the 2, and we get a 2x plus 10. So we have these four terms, and almost all the time, but maybe not every time, but almost all the time, we have two terms that can combine together. So our final product is x squared plus 7x plus 10. Well, today we're learning to factor, which is the reverse process. So factoring is when I give you the trinomial or the polynomial, and you have to try to figure out what are those two factors that multiply together to give that trinomial. So it's a little tricky at first. So, for some people it comes kind of naturally, and then for other people it's a little bit hard to get your brain to think this way. It's the kind of really thinking about and understanding multiplication helps you be a better factorer. When you have two binomials, the first term of the product, it comes from the first two terms in the binomials. So if we have a lead of x squared, we know that we are going to have an x in each of those binomials. The last term also we have a lot of information about. We have this last term 10, and we know that that 10 came from these two numbers multiplying together. So if we see a 10, we can think about, numbers that multiply together to give us 10. The tricky thing is the middle term because it is a combination of things, but they've already been combined when you're looking at the trinomial. So it's factoring is kind of this weird complex process where you're looking at that ending term and you're trying to make the middle term from the factors of that ending term. So really thinking about if you're really stuck on factoring, you can think about multiplying and maybe do a couple of multiplication problems to help you see where the parts are coming from. So here's our first little trinomial to factor. So when you factor, you're going to start by setting up your parentheses for your two binomials. And, you want to notice that this is an x squared. So that means each of our binomials is going to start with an x. Then shift your attention over to that ending number. So we have an 8, and it's a positive 8. So 8 is either 1 times 8 or it's 2 times 4 if we're thinking about whole numbers. Well, I know it's got to be one of these two combinations. Either I have an x plus 1 and an x plus 8, or I have an x plus 2 and an x plus 4. And, if it helps you, you can write out those combos instead of reasoning through it and filling it in later. You could write out the two combos and kind of test them out. In this case, our middle term is a 6x. So this combo with the 2 and the 4, that's the combo that we want to use. X plus 2 and x plus 4. Now, when you write these factors out, it's okay if you wrote it in the other order. That would have the exact same product because multiplication is commutative. So the order that I have the two factors doesn't matter. Either of those two answers is 100% correct. Always with factoring, especially when you're new to factoring or if you've done one that was particularly tricky and hard to figure out, multiply it out and see if you get what you started with. And in this case, we do. So I was able to check my work and verify that I was correct. Okay, factor this expression x squared minus 10x plus 24. I wanted you, a lot of times we do a factoring problem and, all we end up with is, that was weird. All we end up with is the answer. So we look back at our notes and we're like, well, I have no idea how that happened. So I have on your notes this little section that kind of shows you the steps that we think through. So the first step is that you make your sets of parentheses for your binomial factors. Then think about that leading term x squared and put an x as the first term for each binomial. After you do that, you're going to shift your attention over to the ending number, the constant term, the 24 in this case. And if you need to write out the factor pairs, if you can think about the factor pairs in your head, that's fine. If you come up to across one that's particularly tricky and you're not being able to find a combo in your head, sometimes writing it out helps you figure out that a combo that you missed. So here's my combos for 24. And then once you have that list either mentally or on your paper, then you can identify the signs and the factor pair which combine to the middle coefficient. So in this case, a 4 and a 6 is going to help us, and they're both going to be negative because we need a negative 10. So we don't want it to be a positive 10. The trinomial has a negative 10 coefficient. And then your last step is to fill that in. And those are your two factors. X squared minus 10x plus 24 is equal to x minus 4 times x minus 6. Always, 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 you could multiply that out and check and verify that you were correct. So I did this one a second ago to kind of show you that when you look in your notes, sometimes you can't tell where the factors came from or what the process was. So let's go through this one. We set up our two sets of parentheses, we fill in our leading x's, and we think about that number 12. 12 is 1 times 12, 2 times 6, 3 times 4. We're looking for a combo that helps us with that middle term of 7x. So this is the combo that we want, and these are going to be both positive. Okay, let's try this one over here. Set up our parentheses. We put our x's in, and now we're going to think about the number 16. 1 times 16, 2 times 8, 4 times 4. We're trying to get a middle coefficient here of negative 8. So we're going to put a negative with each of those 4s. That still multiplies together to give us a positive 16. And it adds together to give us that negative 8. Always, always, always multiply it out if you need to check. Also, if the two factors are the same, it's more common to write it as a binomial squared. Okay, we've got some more challenging sign patterns here with our pluses and minuses. So we're going to start it exactly the same way we have been. We're going to put our set of parentheses. We're going to put our leading x's in. And now we're thinking about the number 28, and it is a negative 28. To get a negative product, I'm going to have one number that's positive and one number that's negative. I like to just think about the numbers themselves and not worry about the signs very first. Some people like to think about the signs while they're thinking about the numbers, but I like to make my number list first and then think about that middle term and its signs. I know I need one of these numbers to be negative to give me that negative 28, and I need a middle term of negative 3. So it looks like this combo could give me a 3 that's negative if the 7 is negative. So my product is going to be 4 times negative 7. So I can fill those in to get my two factors. And again, remember, if I switch the order of those two factors, that's okay. What would not be okay is if I had switched the signs. If I had x plus 7, this is not okay. And the reason that's not okay, you can see if you multiply it to check. That's an x squared, that's a negative 4x, a positive 7x, and a negative 28. So that's an incorrect factorization because it is a positive 3x instead of what I was trying to factor, which was a negative 3x. So you have to be very careful to get the signs with the correct number. Okay, another thing that sometimes gives people trouble is when we have a number that is not in our multiplication tables. So we have our parentheses, we have our x, we're thinking about the number 26. 26 is a number that is not showing up in our multiplication tables. If you get a number like that and you can't see a combo, start playing in your calculator and dividing things until you can find a combo. 26 is 2 times 13, and that's the combo that we need to get an 11. It is a negative 26, and we want a positive 11, so we're going to put the negative with the 2. So this is going to be x minus 2 and x plus 13. Always, always, always multiply your answer out to check your work if you're worried about it or if you're taking a test. Okay, 2 more of these. Factor each expression. This one, sometimes when there's a 1 at the end, it gives people trouble, so that's why I like to do this one as an example. Our number at the end is a 1, and there's only one way to get a 1. It's a 1 and a 1. But I have a -2 in the middle. So I do have 1s here. To get that to add up to a middle term of -2, they are both a -1, and I could write this as a binomial squared. Okay, this one is a little bit different from the other ones that we have done. All of the ones we've done so far today or in this video have been trinomials, but this one is a binomial. It only has 2 terms. Hopefully you recognize that the term that it doesn't have is the middle term. It has a 0 as its middle term. It has the x squared at the front. It has the constant at the end. It's the middle that is a 0. So we factor this exactly the same way we have been. It's just that we're trying to get that middle term to add up to 0. So the factors of 36 are 1 times 36, 2 times 18, 3 times 12. There's so many. 4 times 9, 6 times 6. We need a combo that adds up to 0. So we're going to use those 6's to get it to add up to 0 for the middle term. We're going to use a negative with one of them. So this is x minus 6 and x plus 6. I can't write that one as a square like I did on the last one because the 2 factors are different. They have a different sign in the middle. That different sign in the middle allows them to cancel out to a 0 middle term. Okay, in class we played a game. All right, so maybe take a minute to practice a few on your pink sheet to make sure that you have the handle on it on your own. Multiply your answers to check them if you're unsure of one. You can do 1 through 12 on the worksheet if you want. And then come back to the video, and the rest of it is a little different, but goes with it, of course. And so we're going to look right now at what should we multiply to get each product. So if I have an x minus 6, what should I multiply by right here to get a 5x minus 30? And hopefully, you can kind of think about that I need a 5 right there to get a 5x minus 30. And in this next one, what would I multiply by right here to get a 2x squared and a negative 14x? Well, it looks like to get the 2 and the 14, I need a 2, but also I have an x squared and an x now, so the thing I would multiply by is a 2x. And what would I multiply by to get a 3x squared and a 12x and a 9? I would multiply by a 3. So every pair of numbers and every pair of terms has what we call a greatest common factor. A lot of times the greatest common factor is 1, but every pair of numbers, every pair of terms has a greatest common factor. A GCF is the largest divisor of both. It's what they have in common. So if I think about the number 12 and the number 18, the factor that they have in common that is the largest is a 6. So I wouldn't want to list a 2 or a 3 here, even though they do both have a factor of 2 and they both do have a factor of 3, because I'm looking for the greatest one, and so that would be 6. The greatest common factor of 15 and 35 is 5. And greatest common factors can include variables if the 2 terms or 2 monomials that you're looking at have a variable in common. So in this case, I have a 2x squared and a 6x. Well, the number that they have in common, the number part of their factor in common is 2, but then they also have an x in common. If you have something like 12x and 18, those do not have an x in common. That would still just be a GCF of 6. They have to both have an x for a variable to be in their GCF. Another thing is that sometimes the GCF can be 1. So if I had 2x squared and 7, their GCF is just a 1. So every pair of numbers and every pair of terms does have a greatest common factor. if their greatest common factor is 1, it's not that useful, but we look for ones that are not 1. So some polynomials have a monomial factor, so a factor that's not a binomial. We just did a whole bunch of factoring with binomials where we had two terms in both of our factors like this, but it can be the case that it's more like a monomial multiplied by a binomial. So we usually put those at the beginning of the factored expression. So if I want to factor 25x squared plus 15x, I might notice, hey, those have a 5x in common. So I write down that GCF first. And then I think about unmultiplying that from the binomial that's here. So I would need a 5x here, and you are kind of thinking about unmultiplying it. So I need another 5x here for that first term to be 25x squared. And then I would need a 3 in my second term for that to be a 15x. So this is called factoring out a GCF, and it gives me a monomial factor instead of two binomials. Sometimes it's just a number, and if there is a number in common, we do want to factor it out. So this, we have a common factor of 8. If I factor or unmultiply that 8, it leaves me with an x minus 9. 6x squared minus 18x, they have a 6x in common. If I unmultiply that 6x, that leaves an x minus 3. If your lead is negative, you want to factor a negative out. You want to get that negative to the front. So this is going to be negative. They have a 5 in common, and they have an x in common. So negative 5x is going to be my monomial factor at the front. And now I'm going to think about what it gets left or when I unmultiply that. So, and the reason we factor that negative out is because we want the binomial to start with a positive number. So this will be a 2x, and then be extra careful when you factor out a negative, it's going to change the signs. This is going to be a minus 3. So always check, you can multiply and check. Negative 5x times negative 3x does give me that positive 15x. I think I said an x with a 3 and I shouldn't have. Negative 5x times negative 3 is 15x. You don't have to write anything out when you're checking your multiplication. Just at least mentally do that quick check. This one has a negative. I have this example here because it's very easy for people to make an error of losing a term. So we have in common here a negative 12, and because the lead is negative, I do want to factor the negative out. That's going to leave a 2x in the first term of the binomial. And then sometimes people are like, oh, I factored out the negative 12, it's gone. But there does need to be a 1 here. We would multiply that negative 12 by a 1 to get that second term. If I only had the negative 12 and the 2x, that multiplies together to give me negative 24x. I don't get that negative 12 if I don't have the 1 when I'm multiplying out. So make sure you don't lose a term. Trinomials can have monomial factors as well. So in this case, maybe this looks different than the other ones we did because of that 2 that's with the x in the front. But you might notice that all of those numbers in the expression are even. So we can factor out a 2. That leaves x squared plus 6x plus 8. So I look for the number that all of them have in common as a factor, and I factor it out. Now with the trinomial, I'm not finished yet. I still want to continue factoring, and I want to now focus my attention on this and think about, can I break that into two binomials? When you do this, don't lose the 2. The 2 is still present. It's one of the factors. This is 2 times a binomial times a binomial. So don't let that 2 disappear. Thinking about x squared plus 6x plus 8, I know those two binomials are going to lead with an x, and an 8 is a 2 times a 4, which does help me get the two factors. So this is my factorization of 2x squared plus 12x plus 16. It's just twice x squared plus 6x plus 8. So don't lose the 2. The 2 is part of it. Okay, let's try, we're going to do 2 more of those, and then we'll be done. So 3x squared minus 6x minus 45. I want to think about what do those all have in common, and they all have a 3 in common. So my 3 terms, once I factor that 3 out, are going to be x squared minus 2x minus 15. I've got a trinomial here, so I'm going to try to factor it into 2 factors. They're both going to lead with an x. And now I'm thinking about the number 15. 1 times 15, or 3 times 5. I'm looking for a negative 2, so that's my combo with a negative on the 5. So negative 5, positive 3 in my factors. So 3x squared minus 6x minus 45 is equal to 3 times x minus 5 times x plus 3. Okay, last one. We've got an expression 8x to the third plus 48x squared minus 56x. Hopefully you noticed right away that they all have an x in common. They all also have an 8 in common. So we're factoring out an 8x. That leaves us with x squared plus 6x minus 7. We want to try to factor that trinomial now. So we're going to lead with x's, and our number at the end is a 7. So the only way to get a 7 is 1 times 7. And to get a positive 6, I just need one of the numbers to be, to get a negative 7, I need one of the numbers to be negative, and to get a positive 6 in the middle, the 7 should be positive and the 1 should be negative. So that is my factorization. I don't know why I'm rewriting it. Just for funsies, because there's a weird space that was kind of bugging me. All right, so that is factoring in a nutshell. If factoring is tricky for you at first, that's pretty normal. Just stick with it, and you will eventually get to be very, very fluent at it. Factoring is one of those math things that never goes away, so just do your best to keep at it until it really clicks for you. All right, that's it. Thanks a lot for watching this, and have a lovely day.